Okay, so let's take a look at question 6. So in question 6, we are asked to find A1, A2, T1, and T2. So let's look at what we know. We know that the mass of the rope will be equal to 0, and that we have no friction going into this problem. Okay, perfect. So let's begin. In order to begin finding the acceleration, we have to use the formula T minus m1g equals m1a. We are given two equations for the acceleration and for tension. And we can go ahead and start to rewrite them. We do this to make it easier to use the equation. To do this, we start by finding the acceleration. We use T1 minus m1g equals m1a. We know that it is in the positive direction, so we have positive m2g minus t equals m2a. We cancel out those values, and once we do that, we get m2g minus 1g equals 1a plus m2a. We use m2g minus m1g equals m1 plus m2 times acceleration. And in order to convert it, we need to divide our values. So to do this, we move over m1 plus m2 to the left side of the equation, and we are going to divide it by m2 minus m1 times g. In order to equal our accelerations, so that we can plug in our values for m1 as well as m2 and rg. So we have 90 over 110 times 9.8 equals 8.02, and that's our acceleration. Now that we have the acceleration, we can figure out tension. So we can use T1 equals M1A plus M1G, and we can plug in all of our values and get 10 times 8.02 plus 10 times 9.8, which is gravity, and we get 178 for T1. Okay, now moving on to our A2 and T2, we basically do the same thing we did for A1 and T1. We use the formula T minus M1G sine theta equals M1A. And so when we do this, we follow the same steps as before, and we get that A2 equals 8.46, and we get that T2 equals 133.6. And that's all for question 6. Thank you.